Okay, we're going to go ahead and do solving equations with rational exponents. So we talked about rational exponents are just fraction exponents. So we're going to solve equations that have those in them. Okay, so isolating the expression is our first step. So when we're solving, we want to get it by itself. Okay, we want to get that fraction exponent by itself. Now, then we'll raise each side by the reciprocal exponent. Remember, reciprocal means we're going to flip that fraction, okay? Something else that we're going to have to deal with, and we'll talk about it in a couple examples later, is if the denominator, or the bottom of that fraction when we flip it, once we flip it, if the denominator is even, you must have a plus or minus, and we'll talk about the reason why a little bit later. Once we do that, though, we're going to have then solve for x, and then we're going to check for an extraneous solution. Extraneous solutions are just solutions that sometimes won't work, because remember, fraction exponents are dealing with radicals, and when we have different kind of roots, like even roots, sometimes we have two solutions, or we can't have negatives, or those are imaginary solutions. So you just got to double check to make sure that it works out is all. Okay, guys, let's look at this example. So first thing we need to go ahead and get the 1/4 power part by itself. So we're going to have to add 7 to both sides. And when I do that, I'm going to be left with just 5x plus 6 to the 1/4 power equals -5 plus 7 is 2. Now we're going to go ahead and raise it to the reciprocal power. So the reciprocal power would be 4 over 1, and if I do it to one side, I have to do it to the other side. Okay. The left side, it just becomes 1, so these kind of simplify to just 1, so I just have 5x plus 6 equals, and this is just 2 to the 4th, which we just know is 2 times 2 times 2 times 2 times 2, which is 16. Now we'll just solve for x, so we're going to subtract 6. Okay, so 5x equals 10. Divide by 5, so x equals 2. Now we're just going to go ahead and plug this back in to double check to make sure that it works out. So we're going to do 5 times 2 plus 6, all that to the 1/4 power, minus 7 equals -5. Now 5 times 2 is 10 plus 6 is 16. 16 to the 1/4, well, you know that's just the 4th root of 16. Which is 2. So I have 2 minus 7 equals -5. Well, that's just -5 equals -5, so it actually ends up being a true statement. So we know that it works. Okay, this is our final answer. Okay, let's go ahead and look at this example. Okay, first thing I need to isolate it by itself, so I'm going to go ahead and subtract 1 from both sides. Okay, so then I'm left with 4x minus 1 to the 2/3 equals 9. Okay, now we're going to go ahead and raise both sides to the reciprocal power. So I'm going to raise both sides to the 3/2. Now we talked about this in the steps. If I look right there, that's an even number. So when I go to do this right side, that's the square root of 9 cubed. So back at like unit 1 and unit 2, we talked about when we had to square root both sides, we always needed a plus or minus sign. Okay, so same thing here. Since this number, if this is even, we have to have a plus or minus sign because it's going to be an even root, so we know we need to have both a positive and negative. Okay, so let's do this. The square root of 9 is 3. Then we have 3 cubed, which is 27. Okay, so plus or minus 27. And then on the other side, this just simplifies to 1, so we can just cross that off, and we have 4x minus 1. Okay. Now let's just solve. So now we have to break this up into two different ones. We have 4x minus 1 equals 27, the positive, and then 4x minus 1 equals negative 27. Okay. Add 1 to both sides, so 4x equals 28. So x equals 7. Okay. Your first one. And then we're going to add 1 to both sides. So we have 4x equals negative 13. Or sorry, not negative 13. negative 26. Okay. Divide both sides by 4. X equals, we can simplify that to negative 13 over 2. Okay. And I'm going to go ahead and save you a step. When you do plug it back in, both of those work out. So that's our other answer, and it is okay to have two answers for some of these problems. All right, let's look at another example. All right, guys, here's the last example. All right, if I look, it's already isolated, so I don't have to do that step. I can go ahead and raise it to the reciprocal power, which would be 4 over 3, since it's 3 over 4. So that's both sides. Now, if we look at the denominator, it's odd, so I don't have to worry about that plus or minus. Okay, so this side just becomes x plus 1, because these simplify, equals, and this is going to be the cube root of 8 to the 4th. Well, cube root of 8 is just 2. Then 2 to the 4th, we can use our chart to help us out there. But 2 to the 4th is just 16. Okay, subtract 1, so x equals 15. Now we can plug it in to check to see if it's extraneous. So 15 plus 1 is 16 to the 3/4. Well, that's just the 4th root of 16, which is 2. Then 2 cubed. Okay, 2 cubed is 8, so 8 equals 8. So this does end up working out. Okay, so this does work out. So our answer is just that x equals 15. Okay, it asks when do we have to use the plus or minus sign when we're dealing with these rational exponent equations. Remember, when the reciprocal denominator is even. Because remember, anytime we do a even, like a square root to both sides of the equation, we have to have the plus or minus sign, because it could be a positive or a negative. All right, go ahead and get started on your practice problems.